Okay, today our topic is Pipette method. So Pipette method is the type of in the process of sedimentation analysis. Generally, Pipette method is generally used when the particle size is less than 75 micron. So whenever the particles is less than 75 micron, we cannot sieve through a set of sieves. So in order to sieve the particle size which are less than the 75 micron, we have to use the Pipette method or Hydrometer method. This Pipette method we need soil suspension is required. So in this method we are using 500 ml of soil suspension is required. So the soil suspension required is already discussed in the previous lecture. The process is like 50 grams of overdray is taken of the soil, 50 grams of dry soil. We have to add 100 ml of dispersing solution. The 100 ml of dispersing solution is preparation is like 33 grams of sodium hexametaphosphate plus 7 grams of sodium carbonate to 1 liter of distilled water. So out of this 1000 ml of suspension, we have to take 100 ml of suspension to 50 grams of soil. So after the process of the mixing process, we have to heat about 10 minutes. After the total mixture is transferred to a mechanical cup of stirrer about 3 by 4 full. Now again in this mechanical stirrer, we have to stir the soil suspension about 10 minutes. After the soil suspension is stirred about in this mechanical stirrer, we transfer the soil suspension to a 75 micron sieve. Whatever the particles which are retained on the 75 micron is going taken into a set of fine sieves. Whatever the material which is passing through the 75 micron is taken to a sedimentation tube, or the soil suspension is taken into a other container. So whatever the suspension which are passing through the 75 micron soil suspension is taken into a sedimentation tube. This is the process generally follows in the sedimentation analysis. The same process same process is whatever the process is done. The pipette method also same, but we have required only 100 ml of soil suspension is required. Okay, so for this we have to take in this process, first we have to find the calibration of the pipette. The calibration of pipette means for the determination of the volume of the pipette. So in order to find this is the pipette. In this pipette we have to find this volume of the pipette. So in order to find this volume of the pipette, first we have to calibrate it. So how much what is the volume of this pipette. So for this we have to calibrate this pipette. So the procedure is like this way. So first we have to go through these points. First, this is known as sedimentation tube. So in this sedimentation tube we are taking this soil suspension. The soil suspension is preparation is like above sedimentation analysis which are discussed in the previous chapter. So once you go through the last video, you can get the idea. So in this soil suspension, we have prepared 1000 ml. Out of 1000 ml, we have to take only 500 ml soil suspension. The 500 ml soil suspension is taken into the sedimentation tube. So this tube is known as sedimentation tube, and it is known as a pipette. And it is also this total unit is known as suction unit, and it is mounted on a sliding carriage. So this is known as sliding carriage. You can move this up and down like based on this sliding carriage. So this total mechanism, this total equipment is known as pipette method equipment. So once again I'm repeating you, this is sedimentation tube, this is pipette. So this is total suction unit. So among this suction unit we have the sliding carriage. So this sliding carriage usually usage of this sliding carriage is, so to in order to embrace the pipette into the sedimentation tube, or we can take the pipette out from this sedimentation tube by using this sliding carriage. Okay, so in order to find this volume of the pipette, first we have to take a distilled water. So first we have to take a distilled water in this sedimentation tube. Okay, first we have to take the distilled water in the sedimentation tube. So after the taking of the distilled water, now by using sliding carriage, now the total mechanism is by releasing of the clamp. Now the sliding mechanism starts, and it goes on to the deeper and deeper, and it finally takes reaches to the sedimentation tube and open this nozzle, and automatically the suction, whenever the suction is processed, whenever the air is transferring from this tube, automatically the water is reaches to this position. After whenever the water is sucked to the pipette, so after the suspension, after the water is suction in this pipette, the valve is closed. Okay, after the water is flowing through this pipette, and then the valve is closed. Now the after the valve is closed, now the sliding carriage is moving and taken to the top position. So now the stop cock is turning into other way. Automatically the water in the pipette is taken into a whatever the container or any weighing bottle. Okay, so now transfer this liquid into the transfer this water in the pipette is transferred to the weighing bottle or any weighing container by the mass of the water in the bottle is grams is equal to the volume of pipette in ml. Okay na? ఏంటంటే అండి, సో ముందు దీని యొక్క వాల్యూమ్ ఆఫ్ ది పిప్పెట్ క్యాలిక్యులేట్ చేయాలి. ఈ వాల్యూమ్ ఆఫ్ ది పిప్పెట్ క్యాలిక్యులేట్ చేయడం కోసం ఏం చేస్తామంటే, ఈ సెడిమెంటేషన్ ట్యూబ్‌లోకి ఒక వాటర్ తీసుకుంటాం. వాటర్ తీసుకొని ఏం చేస్తాం, ఈ పిప్పెట్‌ని ఇందులో ముంచుతాం. జస్ట్ ఫర్ యూ హావ్ టు ఇంప్రెస్ దిస్ పిప్పెట్ ఇంటూ ది సెడిమెంటేషన్ ట్యూబ్ ఆఫ్ కంటైనింగ్ వాటర్. సో ఎప్పుడైతే ముంచిన తర్వాత మనం ఏం చేస్తాం, ఈ వాల్వ్ ఓపెన్ చేయగానే డ్యూ టు ద వాటర్ సక్షన్ చేసుకోగానే ఈ వాటర్ అంతా ఇందులోకి వచ్చేస్తుంది, ఈ సక్షన్ ట్యూబ్‌లోకి. ఎప్పుడైతే సక్షన్ ట్యూబ్‌లోకి వాటర్ అవ్వగానే క్లోజ్ చేసేయాలి. క్లోజ్ చేయగానే అది అట్లే ఫిక్స్ అయిపోయి ఉంటుంది. సో నౌ ఏం చేయాలంటే నెక్స్ట్ ది సెడిమెంటేషన్ ఈ స్లైడింగ్ జార్‌తో దాన్ని పైకి రొటేట్ చేయాలి. సో పైకి తీసుకెళ్ళగానే వెంటనే సో దాన్ని ఏం తీసుకెళ్ళాలి, ఒక వేయింగ్ బాటిల్‌లో గాని, వేయింగ్ గ్రామ్‌లో తీసుకొని దాన్ని వాల్వ్ ఓపెన్ చేసి సో దీంట్లో ఉన్న వాటర్‌ని రిలీజ్ చేసేస్తే ఆటోమేటిక్‌గా దీన్ని వాటర్ రిలీజ్ చేస్తాంగా ఆటోమేటిక్‌గా దీనికి ఎంతో కొంత వెయిట్ ఉంటుంది. సో ద మాస్ ఆఫ్ వాటర్ ఇన్ ద బాటిల్ ఇన్ గ్రామ్స్ ఈజ్ ఈక్వల్ టు ద వాల్యూమ్ ఆఫ్ ది పిపెట్ ఇన్ ఎంఎల్. So indirectly it gives the volume of pipette in ml. Okay, so with this way we can find out this calibration of the pipette. So the same process for the next step for the soil suspension also. For this next one, so this is the calibration of the pipette process. Next we have to find the sedimentation test. So in this sedimentation test, we have to take the sedimentation tube. In the sedimentation tube we are taking the soil suspension. In the soil suspension we have the water and the solid particles, and also we have the dispersing agent solution. So both all are together at one place, and this soil suspension is taken, about 500 ml of soil suspension is taken into the sedimentation tube. So in the sedimentation tube is taken into a temperature bath. The sedimentation tube initially the sedimentation tube is placed in a temperature bath at 27 degrees centigrade. So 27 degrees about 1 hour. So 1 hour we have to take the sedimentation tube in a temperature bath about 27 degrees. So 27 degrees centigrade. After the 27 degrees centigrade about 1 hour, now the sedimentation tube is removed from this temperature bath for homogeneous suspension. So we are taking about 1 hour the any solid particles which are settled at the bottom of the sedimentation tube. So due to this non-homogeneous suspension, so we have to rotate the sedimentation tube by up and down using the bung provided at the top. Okay, so whenever we take sedimentation tube is placed in a temperature bath about 1 hour, so due to 1 hour any solid particles which are high mass which are settled at the bottom, so this causes a non-homogeneous suspension. So for this non-homogeneous suspension we have to provide homogeneous suspension. For the preparation of homogeneous suspension we have to provide a palm, or maybe we can provided a rubber bung at the top of the sedimentation tube. After the providing of the rubber bung, so we have to move this sedimentation tube by up and down. Automatically the solid particles which are at the top and bottom are uniformly dispersed, and the uniform concentration is provided at the total sedimentation tube. So at the instant time, so whenever the after this process is completed, at the instant time, so we have to take same time at the same place we have to provide the constant temperature as like 27 degrees centigrade. So initially after this process is completed we have to start the process by stopwatch is started to record the time. So whenever the process is completed, then the stopwatch is started to record the time. So after the process of up and down we have to start the process of by stopwatch is started. So initially the sedimentation tube is placed in this setting. So first we have to take at the time of half minute, or maybe taken as 2 minutes. First pipette is taken out about a time of 2 meter interval. First we have to take the pipette is taken into the sedimentation tube by immersed into the distilled immersed in this sedimentation tube at a time of 2 minutes. So before 2 minutes, we have to slowly, okay, we have to slowly immerse this pipette about 20 seconds, about a depth of 100 mm. Okay, so about 100 mm, so about 100 mm, about 100 mm, before the time taking of 2 meter interval, we have to take the 20 seconds. That means 1 hour, 1 minute 40 seconds of time. So we have to immerse this pipette into this salt suspension before 20 seconds of the salt suspension taken. Okay, uh, 1 hour the 15 minutes taken, we have to immerse this pipette about 14 minutes 40 seconds. Okay, like this way. So we have to immerse this pipette before the 20 minutes 20 seconds of the whatever the time interval taken. Okay, after the pipette is immersed in this sedimentation tube, now the valve is open. Automatically the soil suspension is flowing through this pipette and up to the safety bulb, and also now the valve is closed. Automatically the no water is flowing through this pipette. Whenever the process is completed, now the valve is closed, and due to the by using of sliding gear, the pipette is taken out from this sedimentation tube, and transfer this suspension in the pipette is transferred to the again weighing bottle. Okay, so again transfer into the weighing bottle. So in this weighing bottle, the mass of water in this mass of soil suspension in this pipette is indirectly calculated by its mass of solids per ml. Okay, like this way. సో ఏంటంటే సేమ్ అండి, వాటర్ ఎలాగైతే తీసుకుంటామో ఇక్కడ కూడా అంతే, సాయిల్ సస్పెన్షన్ తీసుకుంటాము. సాయిల్ సస్పెన్షన్ తీసుకుని పిప్పెట్ ఇందులో ముంచుతాము. పిప్పెట్ ముంచేసి వాల్వ్ ఓపెన్ చేయగానే ఈ పిప్పెట్ లోకి ఈ సాయిల్ సస్పెన్షన్ వచ్చేస్తుంది. వచ్చేసిన తర్వాత పిప్పెట్ ని ఒక ఏమంటారు, ఈ యొక్క వాల్వ్ ని క్లోజ్ చేయాలి. వాల్వ్ ని క్లోజ్ చేయగానే అయిపోతుంది. సో వాల్వ్ క్లోజ్ ఆపుగానే దీన్ని మళ్ళీ పైకి తీసుకెళ్ళాలి. పైకి తీసుకెళ్ళిన తర్వాత వాల్వ్ క్లోజ్ చేయగానే మళ్ళీ వాల్వ్ రిలీజ్ చేయగానే ఆటోమేటిక్ గా దీంట్లో ఉన్న వాటర్ మనం ఎక్కడైతే వేయింగ్ కంటైనర్ అయితే వేయింగ్ బాటిల్ అయితే వేయింగ్, సో మనం దానిలోకి ట్రాన్స్ఫర్ చేయాలి. సో దాని యొక్క వెయిట్ ని మెజర్ చేయాలి. సో దాని వెయిట్ మెజర్ చేస్తే మనకు ఆటోమేటిక్ గా మాస్ ఆఫ్ సాలిడ్స్ పర్ ఎంఎల్ ఎట్ ద టైం, మనం ఏ టైం అయితే తీసుకున్నాం ఆ టైం యొక్క మాస్ ఆఫ్ సాలిడ్స్ వస్తుంది. సో వేర్ ఎంఎస్ ఈస్ mass of the particle per ml at a depth he at a time 0. So that means at the beginning of the sedimentation process we have to take the mass of the particle per ml at the depth he. Okay, so from this we can find out this percentage finer. So percentage finer is equal to the mass of the solids per ml at the beginning of the sedimentation and the mass of the solids at the time of sedimentation, whatever the time we are taking 2 meters. Generally samples are taken at the time of 2, 4, 18, 15 minutes, 30 minutes. After 30 minutes, we can take these samples about 1 hour, 2 hour, 4 hour, 8 hour, 24 hours. Like this way, in all this process, we have to follow this same process. Immerse this pipette in this sedimentation tube. After the water, after the salt suspension is succeeded into this pipette, after the valve is closed and regain into the original position and transfer this water into the sediment any weighing bottle. Note down this weight. Okay, like this way the same process is continued for 24 hours. Okay, after this samples are taken, now the samples taken in this weighing bottle is transferred to a oven dry about 105 to 110 degrees for 24 hours. Okay, so 2 minutes time of interval the samples taken into 24 hours, and 24 hours of soil suspension is taken into each time interval. We can take the samples taken into oven at a temperature of 105 to 110 degrees for 24 hours to obtain for the mass of solids per ml. So like this way we have to process, we have to follow this procedure in this pipette method. Okay, after this process we can find out the particle size also. Why, how we can find out this particle size? Like this way, here we can take the effective height. The effective height we can take in as 100 mm. So at any time, at any interval, at any temperature, we can take the at a depth of 100 mm. So we have to immerse this pipette about at a depth of 100 mm. Okay, at a depth of 100 mm we can take. So here effective height 100 mm. At the time we can know the time 2 meters or 2 minutes or 4 minutes or 8 in terms of we can convert into seconds. So automatically we can substitute in this above equation. Automatically we can get the particle size. So he we know by effective height we are constantly taken about 100 mm. Time may changes to 4, 8, 15, 30 minutes, like this way. Specific gravity of particles is 2.65 to 2.8, and generally we are taking 2.6 or 2.7. Density of water we can know, we know, and the coefficient of viscosity also we know. So by all these parameters are known, so automatically we can get the particle size also. Okay, like this way we can complete the pipette method. Initially we take the water, and for in order to find the calibration of the pipette. After the preparation of the finding out the calibration of the pipette, we have to go through the sedimentation test. So first we have to take the soil suspension in the sedimentation tube, just to suck the soil suspension into the up to the marking limit. After this after reaching of this marking limit, the transfer the soil suspension into the weighing container. Automatically after they are taken into a weighing container, and after the samples are taken and taken in oven into 105 to 110 degrees for 24 hours to obtain the mass of solids per mm. This is the pipette method. So but however, this pipette have some merits and demerits. The merits is, the pipette method is a standard laboratory method for particle size analysis of the fine grain. So fine grain size, so the best method is pipette method is the best method. So it gives a very accurate method. So but the pipette method have demerits. So the demerits are, the apparatus is quite delicate. It is very delicate and is very expensive, and also it requires very sensitive weighing balance machine. So like zero point 0.1 grams, 100 grams, 2 grams, like, so very light sensitive weighing balance machine is required, and also it is time taking required, time taking method. So because why? Because we start this process, take the total pipette method process is taking about 2 days, because the samples taken about 24 hours. After the samples taken, we have to place it in a dried in an oven at 24 hours. So 24 hours plus 24 hours, we can take this total method completion of this total process about 2 days. So because of this, so it is a time taking method. So in order to take this long time taking, for the short time taking method, next another method is hydrometer method. So this hydrometer method is an instrument used for the determination of the specific gravity of the liquids. So generally this specific gravity, this hydrometer method is used for the specific gravity of the liquids. So as the specific gravity of soil suspension depends upon the particle size. Okay, the specific gravity of the soil suspension is depends upon the particle size. So automatically, so hydrometer can also be used for the particle size analysis also. So in this particle hydrometer method, hydrometer gives the specific gravity of the suspension at the center of the bulb. So in this process, the specific gravity of the suspension is taken at the center of the bulb. So center of the bulb. So here the specific gravity of the soil suspension we can get the at the center of the bulb. This is called as a hydrometer. So at the bottom we have mercury. So this long neck is known as, this is known as stem. So in the stem we have the readings about top we have the lesser values, and the values may be 0.995 to 1.030. At the top of the neck we have lesser value, at the bottom of the neck we have higher values. Okay, so the total the center of gravity is taken about the center of the bulb only. We are neglecting this long stem. So we are taking we are neglect this center of the bulb with respect to this center of the bulb. We are taking the center of gravity only at the center of the bulb only. So we neglect the stem. Okay, next one, and at the initial at the starting of the sedimentation, at the beginning of the sedimentation, all the particles are uniformly dispersed, and all particles are uniformly concentrated. So for this, the sedimentation tube is placed at the top only. So due to the uniform suspension, uniform particle size distribution, the specific gravity of the particles is uniform. So the sedimentation, the hydrometer is placed at this place. After the sedimentation process, at the end of the sedimentation process, the large size particles are in this diagram. So large size particles or small size particles are uniformly dispersed in this diagram, but in this diagram only small size particles are at the top and the large size particles are at the bottom. So due to this non homogeneous and the So due to this non-homogeneous and also the some large particles are settles in the bottom. So due to non-homogeneous, the specific gravity of the soil suspension is may changes at the top and bottom. So due to the changes in the suspension, the specific gravity, the hydrometer goes deeper and deeper. Okay. ఏంటంటే ఇనీషియల్‌గా ఈ వాటర్ సాయిల్ సస్పెన్షన్ తీసుకున్నప్పుడు ఆల్ పార్టికల్స్‌తో పాటు చిన్నవి అన్నీ కలిపి ఉంటాయి కాబట్టి ఒక హైట్‌లో ఉంటుంది. సో, స్పెసిఫిక్ గ్రావిటీ యూనిఫార్మ్‌గా ఉంటుంది. కానీ సెడిమెంటేషన్ ప్రాసెస్ జరుగుతున్న కొద్దీ లార్జ్ పార్టికల్స్ చాలా ఫాస్ట్‌గా డెప్త్ అంటే బాటమ్‌కి రీచ్ అయిపోతూ ఉంటాయి. సో, ఎప్పుడైతే బాటమ్‌కి రీచ్ అవ్వడం స్టార్ట్ అయిపోతాయో ఆటోమేటిక్‌గా ఇక్కడ స్పెసిఫిక్ గ్రావిటీ ఒకలా ఉంటుంది. ఇక్కడ స్పెసిఫిక్ గ్రావిటీ ఒకలా ఉంటుంది. సో, ఈ రెండిటి మధ్య ఉన్న తేడా వల్ల ఏమవుతుంది, ఈ హైడ్రోమీటర్ అనేది లోపలికెళ్తూ ఉంటుంది. సో, దిస్ హైడ్రోమీటర్ గోస్ ఆన్ deeper and deeper. So whatever the sedimentation particles or large size particles goes on deeper and deeper, automatically the hydrometer also goes down deeper and deeper. So like this way, the hydrometer method is followed. Okay, next one. So like this way, in the long stem we have the readings from the 0.99 to 1.030. Like these values are so this is known as the height of the bulb, and it is the height of the stem, whatever the water level is taken at the level. Okay, so again same in this method also we have to find the calibration of hydrometer. In this last pipette method we have to find the calibration of the pipette. Like this way we have to find the calibration of the hydrometer also. Okay, so in order to find this calibration of hydrometer, first we have to take this hydrometer in a jar, about to taken about 2000 ml of water. So now this hydrometer is taken into in this jar. Automatically initially the water level is at AA level. So whenever this hydrometer is immersed in this jar, automatically the water level is rises. At the BB level, the BB layer, the water level may rises due to so half of this height only. So the volume of the height of water level rises is indirectly calculated by how we can indirectly calculated by the rise of water level by its effective area. So the volume of hydrometer, the volume of the hydrometer is can be indirectly measured by it's the water level is how much water level is rises by its uniform cross sectional area of this area. Okay, like this way we can calculate the volume of the hydrometer. So in order to find this effective depth, whenever the hydrometer is immersed in this jar or in this jar, automatically the water level rises from BB level to B1 dash, and A layer is rises to A1 dash. Here the water level rises to half of this height only, because the total this is total center of the bulb. So out of the center of the bulb, only half of the portion is immersed at this layer. So for this, therefore the volume of the height of the water level rises due to hydrometer is VH by 2A. So here the total hydrometer is immersed in this portion about to this layer, bottom of this layer. So due to this, the total water level, rises in this area. So the total water level is rises due to the hydrometer. So indirectly we can obtain by the volume of the hydrometer by its cross sectional area. We can get the height of the water level. So due to the immersed in the hydrometer. Okay. ఏంటంటే హైడ్రోమీటర్ని ఇందులో ముంచగానే వాటర్ లెవెల్ ఇక్కడ ఉన్నది కాస్త ఇక్కడికి, ఇక్కడ ఉన్నది కాస్త ఇక్కడికి వెళ్తుంది. సో దీని హైట్ మెజర్ చేయడానికి ఎలా అంటే ఎంత వాటర్ అయితే రైజ్ అయిందో బై ఇట్స్ క్రాస్ సెక్షనల్ ఏరియా చేస్తే మనకు ఆటోమేటిక్గా దీని హైట్ తెలిసిపోతుందండి. ఓకే, సో మనం మీటర్ని ఇందులో ముంచగానే ఒరిజినల్ వాటర్ లెవెల్ నుంచి కొంచెం వేరే హైట్కి వచ్చేస్తుంది. సో దీని హైట్ రావాలి అంటే ద వాల్యూమ్ ఆఫ్ హైడ్రోమీటర్ బై ఇట్స్ క్రాస్ సెక్షనల్ ఏరియా ఇస్తే మనకు ఆటోమేటిక్గా దీని యొక్క హైట్ వచ్చేస్తుంది. అట్లా మన యొక్క ఎఫెక్టివ్ డెప్త్ ఫైండ్ అవుట్ చేయడానికి ఇంకో ఇక్కడ మీకు హెచ్ కనిపిస్తుందిగా 1.020 1.0. సో ద మార్కింగ్ ఆఫ్ దిస్ వాటర్ లెవెల్, సో లైక్ హెచ్ లైక్, సో ఆటోమేటికలీ ద హెచ్ we can indirectly known from this stem to whatever the water level. So we can get the h, we can get the height by its center of the bulb, half of its total height of the hydrometer can indirectly calculated by its vernier calipers or any other instrument. So next, volume of the hydrometer can rises to this hydrometer. So like this way we can calculate the volume of hydrometer by its cross sectional area. We can get the total effective depth at which the specific gravity is determined. So in this depth now we have to find the specific gravity in this layer. Okay, at this depth only the specific gravity of the liquid we can find this at this depth. Okay, next. Okay. Mm. So next, the marking on the hydrometer stem gives the specific gravity of the suspension at the center of the bell. So whenever the hydrometer is immersed in this water, automatically it gives this specific gravity at the center of the bulb only. Okay, it gives this specific gravity of the soil suspension at the center of the bulb. So the hydrometer reading can be indirectly calculated by the hydrometer stem reading minus unit of digit into 1000. So we can get, ultimately we can get the value of hydrometer reading. So hydrometer reading at one place, and the um, h we can know, and height of the bulb we can know. So volume of hydrometer, and also by dividing its cross sectional area, automatically we get the effective height from whatever the hydrometer reading, we can get the effective rate. So by placing of the hydrometer reading at on x-axis and the effective depth on y-axis, automatically we can get the this graph like a straight line. So as the sedimentation progress, the specific gravity of the suspension decreases, hydrometer goes deeper and deeper, and the effective depth increases, the hydrometer reading is decreases. So like this way. So at the after the sedimentation process goes, automatically the larger particles is settles at the bottom. Automatically the specific gravity is decreases. The hydrometer goes deeper and deeper. So automatically we can get the hydrometer reading value. We can get the lesser values. Why? Because you see, if the hydrometer goes deeper, like at present the hydrometer is in this place. After the sedimentation process, the hydrometer goes deeper and deeper. Automatically we can get the one. So 1 minus 1 into 1000, we can get the only zero value. So like this way we can decrease we can obtain the hydrometer reading values decreasing manner. Okay, like this way we can find we so once again. Okay, like this way the as the specific gravity of suspension decreases, the hydrometer goes deeper and deeper. Why the hydrometer goes deeper and deeper? Because of the decreases in the specific gravity of the suspension. By the specific gravity of the suspension is decreases by which way? Due to the large particles are settles at the bottom. So due to the larger particle settles at the bottom, the specific gravity of the suspension is decreases. So after the specific gravity of the suspension decreases, the hydrometer goes deeper and deeper. So as the hydrometer goes deeper and deeper, automatically the effective depth increases, because the h value decreases. Automatically the height will be gained. So automatically the effective depth increases. Okay, the hydrometer reading is decreases. Okay. Okay, we have only 3 minutes, so just completely next now the test procedure. In this hydrometer method, we have to take the same exact 1000 ml of soil suspension is prepared. In the whatever the in the previous class, the preparation of the suspension is same as this process, same as this process. Just to take 50 grams of 50 grams of overdrained soil, take 100 ml of soil suspension to this 50 grams of soil. So after this preparation, like this total at the end, we can get the 1000 ml of 1000 ml of soil suspension. Now the 1000 ml soil suspension is taken into this sedimentation tube, or maybe glass jar, and now the the hydrometer is placed in this jar. So after this jar is placed in the at the time of jar, so we note the time. So initially placed in this jar, we have to provided a rubber bung. At the same process, we have to place this about 27 degrees at a constant temperature, and also provided a rubber bung, and turn this sedimentation to up and down, like this way. After the sedimentation process up and down, now the place this sedimentation tube at a place, and immerse this hydrometer in this place. Automatically we can start the stopwatch at the time of at the time, but when the hydrometer is immersed in this jar. So now start the stopwatch. Now at the time of 0.5 seconds, now hydrometer is immersed in this jar. Take the hydrometer reading. So next 1 meter, next 2 meter, next 4 meter, 8 meter, 15. Like this way, we have to each time interval and 1 hour, 2 hour, 4, 8, 24 hours. Each time we have to place this hydrometer in this jar. In this jar about 20 seconds before the time interval. So if we take 1 hour, if we take the sample at 1 hour, so uh, uh, at the time, that means 59 minutes 40 seconds before the hydrometer is placed in this jar. So note down the hydrometer reading. So after the hydrometer reading, so note down the hydrometer. Like this way, after the time taking process, the large particles are settles at the bottom. Automatically hydrometer goes deeper and deeper, and at the time after the 24 hours, again solid particles, the large particles is goes deeper and deeper. Automatically the hydrometer also goes deeper and deeper. Okay.